Up next, we have Josh Barker, who's from Red Hat and talking about bots versus cattle.
When I started working on automating database services, I found configuration management not quite adequate for my needs. And so I was actually looking for kind of a next wave of automation. And so I got really involved with container orchestration because I thought that was where it was, our sort of third wave. Only I discovered that instead what we were doing with container orchestration was just redoing what we'd done before with configuration management. Not really doing new things or thinking of things in new ways, which leaves me questioning what is that next wave of automation, the stuff that I need to automate my data services. And that got me thinking about metaphors, like the famous DevOps metaphor of pets versus cattle. And while this is good for thinking about scaling, it's also bad in a way. It's particularly bad to think of services as cattle. Because, well, let's face it, cattle are dumb. And you can kind of get them going in one direction, but they're just as happy to go off a cliff as anything else. So you're really dependent on very smart and highly centralized management. And that centralized management becomes its own set of problems and limitations. Not just limitations on scale, like infrastructure scale and especially people scale, but actually your centralized management service then becomes its own single point of failure, either the software or the people that you need to manage it. Now, this got me thinking about a game I used to play as a kid, something called Robo Rally. And the idea of Robo Rally is that you actually have a set of cards to try to design a program for your little robot, and you send it into a robot arena to battle other robots. And the way you generally lost was you collided with something unexpected. And this got really frustrating for me because what I really wanted to do was write little programs that would be based on the different events that the robot could encounter so that it could actually handle them properly. And that's actually kind of what I want for my services too. I want my services to respond to deployment and configuration and availability events and be programmed to just do the right thing in each case. Now that sounds like a tall order, except that we actually already have a pretty good model, a mental model for handling this. It's something called a state machine. And the idea for a state machine is that any event-driven code can be modeled as an input event, two or more states, and the transitions between them. So the advantages of this are that you can actually write fairly simple testable logic. Not just test that you get the right outcomes, but test that, for example, all combinations of events and current states are handled, which means that you can then be ready to respond to anything. So let's think about how we would model services as bots. They need to initialize themselves. They need to know their own state. They need to share that state with the environment. And then they need to change their state in response to events. Now, putting that in more concrete terms, what we're talking about is self-configuration, a local state store, a distributed configuration store, and an event-driven response loop. That actually doesn't sound all that complicated. And it's not all that complicated. For example, if I was automating Postgres, I might write some sophisticated init code, a local daemon which maintains state, write that state to etcd, and then pull etcd for changes. In fact, that's exactly what I and a bunch of other people did for something called the Petronia project. This is an example of one of our little state machine diagrams from the Petronia project for the initialization of a new replica, where we check and find a master and then transition from the state of unknown to replica. Now, some of these state machine diagrams get more complicated, like, for example, the one for failover and electing a new master. But these can all be modeled as small state machines, which actually means that the code that we write behind them is simple and thus a lot less buggy. Now, I'm not the only one to start thinking about services in this way. I'm not even the first one. A lot of other people have been looking at this in the Postgres world and elsewhere, and things like Habitat and other frameworks and NoOps. But where we really need to look at it is when we're designing the applications themselves, not just in the frameworks. Like, look at how you can make your application self-configuring and store and share state, and rewrite your management as actually a set of state transitions. For example, if we're looking at initializing a simple web application, we might initialize it with a DCS connection and node name, and that's it. And it gets the rest of its configuration from the distributed configuration store, pulls new code from DIT, launches, self-configures, and launches. That makes scheduling that very simple. Now, we are going to get new problems with a new paradigm, things like race conditions and lagginess and that sort of thing, and the fact that we need new frameworks for writing and testing these state machine-based things. But I think those are problems worth solving. As a matter of fact, as an ops person, I think those are the only problems worth solving because we need smarter and better automation. So let's build it.
Good job.